Research and development by the U.S. Department of Energy's Office of Fossil Energy and its National Energy Technology Laboratory, or NETL, advances transformative science and innovative technologies to provide affordable, reliable, and responsible energy from fossil fuels.
Fossil energy sources constitute over 80% of the country's total energy use, and it's vital to the nation's security, growth, and economic prosperity. R&D by the Office of Fossil Energy and the National Energy Technology Lab, or NETL, is focused on developing and demonstrating advanced power generation and carbon capture, utilization, and storage technologies for both the existing facilities and new fossil fuel power plants.
NETL and the Office of Fossil Energy are conducting focused research into a variety of advanced fossil energy technologies that can then be accelerated with the help of additive and other advanced manufacturing techniques. Advanced manufacturing research helps to improve performance, increase efficiency, lower the capital and operating costs, and shorten manufacturing cycles while reducing the emissions and extending product lifespans.
DOE is funding research to modernize the grid, improve the existing coal-fired power fleet, and develop the coal plants of the future needed to provide secure, stable, and reliable power.
Our Coal First initiative focuses on coal-fired power plants that are capable of flexible operations to adapt to the modern grid, use innovative, cutting-edge components that improve efficiency and reduce emissions, and are smaller in size than today's conventional utility-scale coal power plants.
Researchers are using integrated design processes that couple computational design optimization with additive manufacturing capabilities to create novel, efficient reactor geometries customized for new carbon capture sorbents, solvents, and membranes.
DOE has a successful track record of advancing carbon capture, utilization, and storage R&D. The U.S. is the world leader with investments in projects like Petronova, the world's largest carbon capture, utilization, and storage project associated with a coal-fired power plant, the Air Products and Chemicals facility in Port Arthur, Texas, and the Archer-Daniel Midland Ethanol facility in Decatur, Illinois. We will continue R&D leadership in CCUS by leveraging NETL's technical expertise and working with external partners.
The Advanced Turbines program is focused on the research, development, and demonstration of revolutionary, highly efficient, and near-zero regulated emission advanced turbine technologies intended to enable cost-competitive, fossil fuel-based power generation, including coal and natural gas, with lower emissions. Advanced and additive manufacturing technologies will reduce cooling requirements in pursuit of DOE's goal of 65% combined cycle efficiency. Researchers are using selective laser melting to explore additive manufacturing processes suitable for nickel-based superalloys to make large gas turbine components. Researchers are working to develop and demonstrate an innovative modular system intensified with microwave catalysis, which allows simultaneous production of high-value chemicals such as aromatics and hydrogen generation via direct, non-oxidative natural gas conversion. Researchers are working to develop next-generation sensors and controls. One final result will be a fully packaged sapphire optical sensor capable of deployment in gas turbine applications at temperatures more than 1,000 degrees Celsius and pressures up to 1,000 pounds per square inch. Researchers are working on a three-step additive manufacturing process for fabrication of solid oxide fuel cells. An additively manufactured SOFC would enable fabrication of high-performance complex geometries at a potentially lower cost than current methods. Researchers are working to produce the world's most advanced power cycle for fossil-fueled, nuclear, and concentrated solar applications. The team is working to apply advanced alloys developed through the Office of Fossil Energy for castings and drawn products. Many traditional casting processes are being optimized for new materials and new ceramic cores. Researchers are working on advanced manufacturing technologies to transform domestic coal into high-value commercial products, including stain and water-resistant textiles, electronic displays, carbon nanomaterials, and 3D printing materials.
NETL and the Office of Fossil Energy are driving cutting-edge, collaborative, cost-shared applied research in advanced manufacturing that will ultimately stimulate economic investments, create high-paying jobs. It will also ensure the responsible stewardship of the environment and boost American energy independence.